Ladies and gentlemen, welcome to your first ever general chemistry instructional video. So tonight we are going to talk about observations versus inferences. This is something extraordinarily important to science in general, but especially to chemistry, because we're dealing with things in chemistry that we cannot see. Sure, we can see their effects, but we're going to explain why different things happen. For example, a piece of metal that rusts outside. We can observe it happening. It goes from shiny and silvery to kind of a dull gray and flaky color. But why does that happen? Well, in order to explain things like that, we need to be able to make observations and inferences. So first off, let's talk about observations. This is probably extremely familiar to you guys. You know what an observation is, and there's nothing tricky about an observation in science. It's literally just what you see. So measurements that you can make. The thing about observations is they are fact. They're observations and they are true. There's no guessing on an observation. And there's two types of observations that we make every day. First off, there's qualitative. So think quality, it's the same root word, and these use adjectives. So like when we see an apple, we might describe the apple as red. That would be a qualitative observation. Or if we think of the desert, we describe the desert as dry. Outside during the summer, it is hot. All of those are qualitative observations. And then there's also quantitative observations. So think quantity with this. Once again, the same root word. These deal with amounts, so measurements. For example, if you have a rock and the rock weighs 3 grams, you put it on a scale, you know it weighs 3 grams, that would be a quantitative observation. Or you find a worm and you measure the worm and it is 2 millimeters long. That would be another quantitative observation. So remember these two words because they're going to pop up a lot during the course of this year because we make several qualitative and quantitative observations. Think of a lab. You watch and see what happens, what kind of reaction occurs. That would be qualitative. You use a graduated cylinder or a scale or a beaker to measure something out. That's a quantitative observation. Just remember that both of these deal with facts. These are known quantities, known observations. None of this is guessing work. Then there is inferences. Some of you might be familiar with this word, others not. This is something that we do a lot in science, and actually you probably do a lot in everyday life. You just never knew what the name of the word was. Now, in order for you to make an inference, you first have to make observations. So these do go in step order. You make an observation, you draw an inference. You draw a conclusion based upon those inferences. Usually they're based upon past experience or prior knowledge, and they can change with new observations. So for example, think about that piece of metal that rusts again. If you make that observation and you're looking for an explanation, your guys' past experience, you probably don't know much about oxidation reduction, transfer electrons, cathode, anode, that kind of stuff. And so your inferences that you draw based upon past experiences are probably going to be different than mine are. However, as we go through the course of this class and you learn new things, you're going to gain new knowledge and your inferences are slowly going to change and kind of hone in. So a good example of an observation-inference situation, let's say you go home after school, and you walk into the house, and you smell pizza. Okay, that would be an observation. That would, in fact, be a qualitative observation. And so you can draw a couple inferences depending upon what your prior knowledge is. So you might think, hey, we're having pizza for supper, or someone else had pizza for lunch and I didn't get any. Or maybe mom just got a new perfume that smells like pizza. Past experiences, prior knowledge. Let's say you know that every Monday night is pizza night, and hey, what do you know? It's pizza night. You're going to draw the inference that it's actual pizza that I smell. However, someone else who doesn't have the same experience as you, someone who rarely has pizza, if they walk in the house, they might draw a different conclusion than what you did. So Monday night, pizza night, new observation, you walk into the kitchen, and there's no one there, no pizza in sight. Your inference is probably going to change. And the thing about inferences is there's no such thing as a wrong inference as long as it is drawn upon observations. So for example, if you walk into the house and you smell pizza and you say, hey, Matt Damon must like vanilla ice cream, that's not a good inference because it's not really based upon the observation you just made. So when you go through history and look at science, people back in the day had some what looks like crazy ideas now. And it's not because they were wrong or because they were dumb. It was just because they had a different set of experiences and knowledge that we have now. And so now we draw different inferences, and ours are probably a little bit closer to right than what they were 1,000, 2,000, 3,000 years ago. All right, here's a quick exercise. So what I want you to do is I want you to pause the video and just brainstorm real quick. You go outside and you observe that the grass is wet. Write down some inferences that you can draw from that observation. All right, so here's a few that I came up with. It could have been rain, it could have been dew, it could have been a leaky fire hydrant, or it could have just been the sprinklers coming on and wetting the grass. All of those are inferences. They're all different inferences, and none of them is necessarily wrong, okay? Because we drew them on the observation that the grass is wet outside. Any of those would result in the grass being wet outside. We can gather more evidence, we can make more observations, and then we can further narrow in our conclusions until we come up with a better inference, or an inference that fits the best. So for example, we checked the weather report for last night and it didn't rain, so that wipes that out. That leaves us with dew, leaky fire hydrant, or irrigation outside. We go and we check with the janitor and it turns out they'd run the sprinklers last night. Okay, so then that's going to be our best inference, is that the grass is still wet from the sprinklers running. Pizza, wet grass. Mr. Jones, who cares? This isn't science. It is science. For example, take a look at this picture. All right, what is this a picture of? Did you say atom? How do you know that's an atom? It's a picture, it's a cartoon. Have we ever seen an atom? Do we have a microscope powerful enough to zoom in and see individual electrons, protons, and neutrons inside of an atom? No, we don't. So how have we drawn the conclusion that this is what an atom looks like? It's observations and inferences. Throughout history, chemists, scientists have made thousands and millions of observations about everyday life. From those observations, they have drawn pretty solid and conclusive inferences about what an atom looks like. This right now, we recognize as an atom at this moment. 100 years from now, 50 years from now, 10 years from now, are we still going to have this same picture to describe an atom? Maybe not, because we're going to make new observations, and therefore we can draw new inferences. And I really want you guys to keep that in mind and have a respect and an awe for science because of that. When I talk about an atom and I say, hey, protons, they're in the nucleus of an atom, I want you guys to realize that there were years and years of observations and inferences put into describing that proton inside of that atom. None of these answers were handed to us. There is a lot of manpower that went into figuring these things out for you and me and giving me something to teach.